Biology of moss plants. E.g. Funaria. So we have understand the fact that moss is underclass Bryopsida, and they are the erect types of bryophytes. The outputs are gametophyte and the sporophyte generation. So we're going to talk. We already know the characteristics of moss because we have talked about the characteristics of bryophyte. And let's talk about the structure. We're going to talk about the structure of moss, the habitat, so the life cycle. The habitat of moss are damp environment, shady environment. Like moss are those plants that you found on old walls, old buildings. They looks like green rock attached to old buildings, old walls. Those are moss. So when we talk about the structure of moss, so we have so when we talk about the diagram of moss, so this is the diagram of moss. We have the rhizoid for attachment or anchorage. We have the stem, main stem. We have the leaves, the leaf-like structure. We have what we call the fruit here. Fruit. We have the seta. We have the capsule. And inside the capsule we usually have spores. So we can have the this is the structure of moss. Funaria. So when you talk about funaria, this is the structure. The root is for attachment. The stem hold the whole part of the body. The leaf carry out photosynthesis. So the fruit, the seta, and the capsule is the sporophyte. So we have the sporophyte here, and this one is the gametophyte. So that is the structure of funaria. Now we want to talk about the life cycle of funaria. Or what we call alternation of generation in funaria. Life cycle of funaria. Funaria is a representative of moss. So when we talk about the life cycle of funaria, they carry out sexual and asexual reproduction, but we're going to focus on sexual reproduction. So the sexual reproduction occurs by alternation of generation. They carry out alternation of generation. And when we talk about alternation of generation, we said that it is the existence of plants in two distinct generations. So moss is a typical example of plants that carry out alternation of generation. So in moss consists of both sporophyte and gametophyte generation. But the dominant generation is the gametophyte generation. So in moss, the gametophyte is elaborate. So the gametophyte produces gamete and it reproduces sexually. So the gametophyte produces the sex organ. So in moss, we have the male gametophyte and the female gametophyte. So the male gametophyte produces the male sex organ. Male gametophyte, produce the male sex organ. The male sex organ. Called antheridia. While the female gametophyte produces the female sex organ alright, female sex organ called archegonium. Archegonium. So, while the male sex organ produces the antheridia, the female sex organ produces the archegonium. So that is the part that produces the gamete. So when the male sex organ produces the antheridia is, the part, the sex organ that produces the gamete. So the antheridia produce the gamete. So antheridia produce the male gamete, which is called antherozoid. Antheridia produce antherozoid or the sperm. So that is the male gamete. The antherozoid is the male gamete. And this antherozoid has some characteristics. The antherozoid are usually small, minute, they are bicellate, they are spiral, they are minute, the antherozoid, they are minute, they are bicellate, that means they can, they can move. So these are the characteristics of the antherozoid, which is the sperm. Then the female, which is the archegonium, it is usually elaborate, and this female has a flask-shaped structure. So the female, sex organ, which is the archegonium, have two components, which is the neck as well as the venter. So the egg, which is the female gamete, is produced inside this venter. So when the egg is produced in the venter and the sperm is produced in the antherozoid, all are produced at the apex. When they are mature. So the this gamete, when they are produced, the male gamete, which is the antherozoid, will swim on a film of water collected at the apex to the archegonium. So that is how the male sperm, which is the antherozoid, will swim. It will move toward the female. And also, when the female produce the female, we said that the antheridia produce the antherozoid, while the female archegonium produce the egg. That is the female gamete, while the antherozoid is the male gamete. So the egg, when they produce the egg, it will now secrete a sugary substance that will enhance the movement of the antherozoid. So as the antherozoid swim toward the archegonium, it will enter into the archegonium at the neck region, and it will move directly to the venter where the egg are produced. So let's say the male sperm has been produced in one part, okay, at the apex. Then the other part, the female part, is like this. Let's say it's like this. So the female part, the archegonium, will produce the egg inside this flask-shaped structure. Then the male sex organ, the male gamete, which is the antherozoid, will swim and enter into the archegonium. So fertilization of this gamete takes place at the base of the archegonium. So fertilization takes place. The male gamete will fertilize the female in the archegonium, and after fertilization has taken place, there will be development of zygote. So this zygote will develop a thick coat to become oospore. So at the end of this development, the oospore will now germinate to give rise to what we call capsule. The oospore will germinate to give rise to the capsule. So the sporophyte consists of all the structure, that is the capsule, seta, and that food, becomes the sporophyte. So the sporophyte consists of the food, the seta, and the capsule. After the oospore have developed. So now that our capsule has emerged, so the capsule will now, inside the capsule is also called sporangium. So inside the capsule, the mass of cell inside the capsule will now carry out meiosis, reduction division. Before the spore mother cell. Before first they carry out mitosis, they form spore mother cells. Then this spore mother cell will now carry out meiosis to give rise to spores. So inside the capsule, there will be development of spores. The capsule is called sporangium. So when the spores are being developed, these spores will now start to mature. So upon maturity, the wall of the peristome will break up, releasing the spores. So when the capsule breaks, the spores are released. So these spores will now, be dispersed by the peristome. Alright. So the spores that form itself in a favorable environment will now germinate into what we call protonema. So this protonema is the young gametophyte, and the young gametophyte will now give rise to the mature gametophyte. So let's say the alternation of generation now in moss, alternation of generation in Funaria. Let's say we have our Funaria plant, which is this gametophyte. So this will produce the male and the female gametophyte. Let's say we have the male gametophyte or the female gametophyte. So we said that the male gametophyte will produce the antheridia, while the female gametophyte will produce the archegonia. That is the sex organ. The sex organ, male sex organ, which is the antheridia, will produce the gamete, which is the what? Antherozoid, while the archegonia will produce the egg. So at the end of this, we will have fertilization. So fertilization takes place, there will be formation of zygotes. So this zygote will now form a thick coat to become oospore. Okay, the oospore will now give rise to the sporophyte. So after development, the sporophyte will give rise to capsule or sporangium. The sporangium will now give us spores. The spore mother cell first, before spore mother cell. Then we have spores. Then this spore will now germinate to the Funaria. So for you to understand the life cycle, we have these spores. So these are the stages. In summary, the Funaria produce the male and the female gametophyte. Male gametophyte produce the antheridia, while the female gametophyte produce archegonia, which is the sex organ. The antheridia, which is the male sex organ, produce the antherozoid, which is the male gamete, while the female sex organ, which is the archegonia, produce the egg. So fusion of egg, the male gamete, the antheridia will swim to meet the female gamete in the archegonia. So fertilization takes place and the formation of zygote. The zygote will develop a thick coat to become oospore. The oospore will germinate to form the sporophyte. The sporophyte gives rise to the sporangium, the foot and seta. So inside the sporangium there will be development. Then we have production of formation of spore mother cells, which will lead to meiosis and give rise to spores. So we have our life cycle like this. So let's say this is our gametophyte, and this is our sporophyte. So gametophyte is N, while sporophyte is 2N. So everything that happens here is 2N, everything that happens here is N. So this alternation of generation in Funaria. That is the explanation. So now we said that is how life cycle. That is how Funaria completes its life cycle. But if you want to carry out sexual reproduction, you just carry out vegetative propagation. So let's move to the economic importance. What are the adaptation and what are also the economic importance of bryophyte? Bryophyte, the adaptation. First of all, bryophyte have rhizoid. When we talk about adaptation of bryophyte, one, they have rhizoid. Yeah, this rhizoid helps them for attachment, absorption of water, absorption of nutrients. Two, they also have their body, they have the ability to store water, they have the ability to obtain water, retain water in their body. That's another adaptation. They retain water in their body. the rhizoid can absorb nutrients from the soil. Another adaptation is that they have two life cycles, the sexual and asexual. The sexual stage of their life cycle depend on water, while the asexual stage do not depend on water. Another adaptation is that their sporophyte phase is, area is above, the soil, so that they will prevent them from desiccation. Those are the adaptations. Then when we talk about the economic importance now, economic importance of bryophytes. Bryophytes are, they are primary colonizers. Yes, they help us colonize during succession. They are primary colonizers during succession, or early colonizers rather. They are early colonizers. After the lynching, we have the bryophytes. Then they are also responsible to retard soil erosion. They are also responsible for soil enrichment. Soil erosion, soil enrichment. That is their, economic importance, and they can be used as tracers in plant evolution. So those